Hi there. Today we're going to talk about the sum of the interior angles of a polygon. Remember that a polygon is any two-dimensional shape which is closed. For that we need at least it to have three sides. So the easiest polygon would be a triangle. Okay, and we already know that a triangle, the interior angles of a triangle, so that would be A, B, and C. A plus B plus C equals 180. Okay, so what happens to the rest of the polygons when we start adding up sides? Well, so if we get the next one would be which would be quadrilateral, so that would be four sides. It doesn't have to be a regular one. So let's see this. So the interior angles would be A, I'm going to call them A, B, C, and D. But now look at what we're going to do. We're going to create non-overlapping triangles. So we can draw a diagonal here, and we see that we can create two overlapping triangles, non-overlapping triangles, 1 and 2. Okay, so this new triangle has other interior angles, which would be A1, A2, B, C1, and C2. Okay? So as each one of them is a triangle, we already know that A1 plus B plus C1 equals 180. And that A2 plus D plus C2 equals 180. We can add this up and we can see that A1 plus A2 plus B plus D plus C1 plus C2 equals 360. Okay? But this is A, what we used to call A, this is B, this is D, and this is C. So the interior angles of our quadrilateral will add up to 360. Okay, if we go to the next shape and we try and make a polygon of a pentagon, okay, so that would be 1, 2, 3, 4, 5. Yeah, so we can do 1, 2, 3. Again, it doesn't have to be regular. 4 and 5. So that's 1, 2, 3, 4, 5 sides. Again, we can call this A, B, C, D, and E. And we can do the same trick as we did before and create non-overlapping triangles. If we do that, we can see that we can create this one over here and this one over here. Okay, so basically we can create three triangles where now we have B1, sorry for that, B1 and B2, we have A1 and A2, and we have D1, D2, and D3. And we could do the same thing, it's three triangles, so A2 plus E plus D3, that's 180. B1 plus A1 plus D2, that's 180. And B2 plus D1 plus C, that's 180 again. Okay, so if we add up, all those were our original angles again. So we have that A plus B plus C plus D plus E, the 5 angles are 3 times 180, so that's 540, okay, degrees. So if we extend this to a polygon of n sides, and we see the pattern that we were following here, with a four-sided one we could create two triangles, So that's 4 minus 2 is 2. With a 5-sided polygon, we could create 3 triangles. So that's 5, again, minus 2 is 3. So that extends, you can try it, and that extends to n minus 2 triangles times 180. That is the interior angles of each triangle. So the sum of the interior angles of a polygon is n minus 2, which is the number of triangles I can create, times 180, where n is the number of sides. Okay, so if we had an polygon of 8 sides, we would have that the sum of the interior angles would be 8 minus 2 times 180, which is 6 times 180, which is 1080. Okay, so this we can use this formula to find the interior angles of a regular and a non-regular polygon of n sides. Okay, this becomes very interesting when so the thing that we have what we have talked about is used for both regular and non-regular. What is a regular polygon? Those polygons where all the sides and all the angles are equal. So what the formula works for regular and non-regular polygons, but it becomes very interesting for a regular polygon because not only can we find the the sum of the interior angles, but with that we can also find out what each angle is. For example, we had a five-sided polygon before, a pentagon, n equals 5. So we saw that the sum of the interior angles was 3 times 180, which was 540. Okay, so we saw that a plus b plus c plus d plus e was 540. But now a plus b plus c plus d plus e are all the same. So that's 5 times a equals 540 because they're all the same. A plus a plus a plus a plus a is 5 times a. So we can find out what each angle is just dividing 540 by 5 in this case, which is 108. So in the case where a polygon is regular, we can use the formula of the sum of the interior angles to find also what each interior angle is. And you can get various forms of this in exercises where they give you each interior angle and they ask for the sum, where they give you the sum and they ask you for each interior angle, where they give you the sum and they ask you how many angles does it have, etc., etc. Okay, so how many sides does it have? For example, if they gave us that the sum of the interior angles of a regular polygon was 100, well, of any polygon was 1080, we just had to say that n minus 2 equals 1080, and then we could get that it was 8 sides. For example, our exercise says that the sum of the interior angles is 1080. Okay, we know that for any polygon is this. Okay, so n minus 2 has to be, okay, so n is going to be okay, which is which is 6, plus 2, which is 8. And then we have our original result. Okay, so with the sum of the with the formula of the sum of the interior angles of a triangle of a polygon, we can find any sum of any polygon, regular or irregular. We can find the number of sides if they give you the sum, and we can also use it in regular polygons to find what each angle is.